Okay, in our last class, we discussed about organo-aluminum compounds. More particularly, uh, organo dialkyl aluminum hydride, trialkyl aluminum hydride, and uh, alkynyl dialkyl aluminum hydride. Its preparation and its application in organic synthesis. Today, we will discuss about one more organometallic reagent called organocopper containing compounds. This organocopper compounds, in that the one particular example is called R2CuLi. R2CuLi means dialkyl lithium dialkyl cuprate. So here copper is in the presence of +2 state. So that is the reason it's a cuprate. So lithium dialkyl cuprate. This lithium dialkyl cuprate is also called as a Gilman reagent. So normally there are many questions on this Gilman reagent. Write a note on Gilman reagent. How is the copper or write a note on organocopper compounds in organic synthesis? Okay, so let's give an entry. Okay, so how one can prepare a lithium dialkyl cuprate? So lithium dialkyl cuprate means R2CuLi. This R2CuLi is also called as Gilman reagent. Okay, so how one can prepare? Just by treating organolithium. Okay, this is organolithium. Ri means organolithium. CuI means cuprous iodide. So there is a difference. Cupric means +2. Plus 1 state of copper is called cuprous. +2 state of copper is called cupric. So this is the +1 state. So we can say that cuprous iodide. So cuprous iodide, when it is treated with 2 molecule of organolithium, it gives dialkyl, dialkyl cuprate. Dialkyl cuprate. This is a organocopper compound. And one more thing, so here there is a lithium iodide. So I will explain here, you can observe that. In the presence of lithium dialkyl cuprate, lithium dialkyl cuprate, let's give an entry. Okay. Right. So lithium dialkyl cuprate is a monomer. In solution, it will be in the dimer form. So dimer form means CH3 2 times Cu Li whole twice, as they are not unstable. So they have to be used immediately, and these reagents are used in substitution reaction as well as addition reactions. So that means the dialkyl cuprate, it is available as a monomer, but in solution, this will be available as a dimer, and these are unstable. That is the reason one can use it immediately after the preparation. And these type organocopper reagents are useful in the substitution reactions and also 1,4 addition reactions. So 1,4 addition reactions means alpha beta unsaturated carbon addition. So here what is adding, you know that dialkyl iodocuprate act as a source of R. Suppose R is equal to methyl, it will act as a source of methyl. If R is equal to ethyl, it will act as a source of ethyl, more particularly in the form of carb anion. So that means R will be added to the substrate in the form of anion. So that is the reason it is useful in what is called as substitution reaction. Substitution reaction means what is called leaving group is going out, and nucleophile is in the form of R, which is attached to a copper. It is added to substrate. Right. So let's look into the reactions of organocopper compounds. So these are of two types. One is substitution reaction, another one is 1,4 addition reaction. So in let's take an substitution reactions. So look here I am taking lithium dialkyl cuprate. Lithium dialkyl cuprate. So when it is treated with alkyl halide, so R1-X is called alkyl halide. So what is the product? The product will be the bond formation between the R1 and R2. Here R2, which is attached to a copper, it attacks R1 and X is going out. And these two are the byproducts. Let's not worry about that. The product is R2 R dash. Okay, what it means? It means that there will be a new bond formation between the two alkyl or aryl group. This is an alkyl, or this may be a of course, this is an alkyl. This may be a aryl or alkyl. So there will be a new bond formation between R2 of copper and R1 of alkyl halide. So that is how a new carbon-carbon bond formation occurs. So in this, we are also giving an explanation. So where R may be a primary group, or maybe a secondary group, or maybe a tertiary group, alkyl. And R dash may be a primary, secondary, or tertiary alkyl halides. So that means this may be a alkyl, primary or secondary or tertiary alkyl halide. So this may be a primary, secondary, or tertiary alkyl group. Okay. So let's go to the next one. Next, let's look into what are the types of substitution reactions is possible with the organocopper. copper. So look here, this is the reagent I am taking. So what is the name of this reagent? Name of this reagent is called lithium dialkyl cuprate. Lithium dialkyl cuprate, when it is treated with a substrate. So what is the substrate here? This is an X is an halide. Okay, X is an halide, and this X is halide is attached to a carbon-carbon double bond. So what is carbon-carbon double bond? The carbon-carbon double bond is also called as vinyl group. Okay, so vinyl group. Okay, so what it means, this nucleophilic nature of copper attached alkyl group attacks this carbon, and X is going out. So that means this is the product is obtained. So that means the R which is attached to a copper, it replaces the halide present in vinyl halide. So thereby it gives a substituted product. Similarly, this lithium dialkyl copper, it can react with aryl halide. Ar means aryl group. Aryl group means benzene containing compounds. So that means it is possible to do a nucleophilic substitution to the aromatic system. Normally, aromatic compounds exhibits electrophilic substitution reaction, but in the presence of copper, it also exhibits nucleophilic substitution reaction. That is the specialty about organocopper reagent. That means a nucleophile means the R group attached to the copper, it adds to a aromatic carbon atom, and X is going out. So that means the obtained compound is alkyl aryl group, alkyl aryl compound. Similarly, this lithium dialkyl copper can react with simple alkyl halide, for example, methyl halide, methyl chloride, methyl bromide, methyl iodide, methyl fluoride. So the product is an alkane. Okay, here I will take one more substrate. The substrate name is a long chain halide. So R1 may be a alkyl group. So long chain. So what will happen here? There will be a new bond formation between this R group and this carbon. The X is going out. So that is how the product is obtained. What we can say that a primary halide. This also a primary halide. Okay, so lithium dialkyl cuprate can react with primary halide, so giving rise to a carbon-carbon bond formation product. Okay. Next here I am taking a secondary halide. Secondary halide, when it is treated with the lithium dialkyl copper or cuprate, so giving rise to substituted product. So here what I am taking a substrate. A substrate is called, I think you are aware about this moiety. This moiety is called allylic halide. This group is called allylic group. Allylic halide. That means halogen present to the allylic carbon can be replaced by using organocopper reagent. That means this X is going out, forming a allylic substituted product. And what is this substrate? This substrate is called, this is aromatic, this is alkyl group, or alkyl halide. So name of this compound is called Ar means aromatic compound, alkyl means CH2 halide. Hieralkyl halide, when it is treated with lithium dialkyl cuprate, so it gives what is called as hieralkyl product. So here I am taking C6H11. So C6H11 means what is called as cyclohexyl group. So cyclohexyl group, more particularly halogen containing one. Then what we can say that cyclohexyl halide. So that means the halide which is attached to a cyclohexyl group can be replaced with the R group of the lithium dialkyl cuprate. So forming cyclohexyl alkyl compound. So what is the name of this compound? This name of this compound is called propargyl halide. So look here, you just look into the difference between the allylic halide. So that means double bond CH2 halide is called allylic halide. Triple bond CH halide is called propargyl halide. So that's only the difference. Here double bond means allylic, triple bond means propargyl. So that means this halide can be replaced by using the organolithium cuprate, and the obtained compounds are called propargyl substituted products. So with this, I will go to the next slide, next one, that is reaction with vinyl halide. So reaction with vinyl means double bond. Okay, right. Here, there is a retention of configuration, and reactions occurs at sp2 carbon atom. So why it is retention means the R group, the stereochemistry of the R group is retained. Okay, I think you are aware about, is this a chiral carbon? Because here one more H is there. So that means two H are similar compounds. That is the reason it's not a chiral carbon. Of course, this also not a chiral compound, chiral carbon. But stereochemistry retention means what should be, there should be a double bond here. So there should be a double bond here. So that means if there is a double bond, what we can say that now we can say that this is in a trans position, trans group. So that means in the product also trans is retained. So that means what you need to do, you need to make a double bond here. So that means here what is happening, bromine which is attached to a double bond is replaced with CH3. So what is the name of this compound? It's a dimethyl lithium cuprate. Lithium dimethyl cuprate. So this lithium dimethyl cuprate replaces Br with the CH3. So how means there will be a, what is the stereochemistry present in the substrate that is retained in the stereochemistry of the product. So that is the reason it's called retention of configuration. Here the small thing you need to note down that, so you need to make a double bond here and also make a double bond here. So you make a double bond here and make a double bond here. So here this is a cis configuration after making a double bond here. Then when it is treated with lithium dialkyl cuprate, this bromide is replaced with the CH3 of the lithium dialkyl cuprate, and the retention of configuration is obtained. So how this retention of configuration occurs? So if you want to look into that, then one should look into the mechanism. So this is the mechanism. So look here, I am, what is that? during the mechanism there is a double bond. Okay, so what will happen here? So when a trans compound, what is this trans? This one I am taking. The first one trans compound I am taking here, and this trans one, when it is react with dimethyl lithium cuprate, so what will happen? There will be a bond formation. How the bond formation? There will be a replacement of Br, and there will be a new bond formation between the copper and sp2 carbon atom. So this is the one. Then at this stage, copper will have a -3 state, and it's also called as D8 configuration. And more particularly, it is a square planar, and it is having a +3 state of the copper. And this one undergoes sin elimination. Sin elimination means what? So this bonded pair can form a bond with this carbon, and this is going out. So that is called sin elimination. So that means simultaneous bond formation between the carbon and sp2 carbon atom, and the bond between the copper and carbon is going out. So that is how a retention of configuration. So here there is a trans, this is also a trans. So whatever the stereochemistry present in the substrate, it is retained in the product. So that's called retention of configuration. Then suppose tosylate group. So tosylate group means, I think you know that a primary alcohol. So methyl alcohol is a primary alcohol. Benzyl alcohol is a primary alcohol. Isopropyl alcohol is a secondary alcohol. Okay, that means a primary alcohol or a secondary alcohol when it is treated with PTSA. What is PTSA? Para toluene sulfonyl sulfonic acid. Para toluene sulfonic acid. That means CH3, C6H4, SO3H is called CH3, C6H4, SO3H is called PTSA. So what it will do? It will remove water. Okay, water OH from PTSA, H from the primary alcohol, and there will be a obtained compounds is called tosylates. Okay, these compounds are called OTS is called tosylates. So what is the need of doing this one? Because a primary alcohol OH is the group. So removal of OH is not a better living group. In order to convert OH into a better living group, it is converted into tosylate. Now this OTS will go out. So when there is a approach of nucleophile, here the nucleophile is R group of the copper. So dialkyl lithium cuprate act as a nucleophile. That means there will be a new bond formation between this R and this R. So that's what the carbon-carbon bond formed product is obtained. Okay. So this is about one more substitution reactions of organocopper compounds. So with this, I will take a few more examples. I think you are aware about what is the name of this compound. I think you are aware about borneol. Okay, borneol, when it is treated with PTSA, it will convert into tosylate, borneol tosylate. Okay, otherwise boronyl tosylate. So here OTS is a tosylate that can be replaced with R2 dialkyl lithium cuprate. And here what is the thing important you need to remember? This is not the SN1 reaction. I think you are aware about the SN1 reaction and SN2 reaction. So SN2 reaction means inversion of configuration. So why it is inversion? Because a nucleophile is attacked from the other side. Okay, so that is the reason you will get a inversion of configuration. So whatever the here axial position of the O tosylate, and this one is equatorial position, and this is a inversion of configuration. Okay, and then in the case of Gilman reagent, so here Gilman reagent means dialkyl lithium cuprate is the Gilman reagent. In acidic hydrogen, alpha carbon is not eliminated. So that means you know that this is the carbonyl carbon and this is the alpha carbon, and this alpha carbon is having the alpha hydrogen. So this alpha hydrogen is not eliminated. What it means? It means that it's not Gilman reagent is not a base. It is a nucleophile. So I think you are aware about one more thing. What is that? LDA. What is LDA? Lithium diisopropyl amide. Lithium diisopropyl amide is a base but not a nucleophile. So in this dimethyl or dialkyl lithium cuprate is a nucleophile but not the base because it does not obstruct the proton. So what is happening here? So there will be a new bond formation between the methyl group of the copper and then tosylate attached carbon. So tosylate is going out. It's a leaving group. So this is about what is called as substitution reactions. So more, and I will take one more example also. So here reaction with allyl halide. So allyl halide means C double bond CH CH2Cl. Group is called allyl chloride. Okay, C double bond CH CH2 group is called allyl group. So what will happen? A allylic chloride when it is treated with dimethyl copper lithium. So there will be a new bond formation between this carbon and methyl group of the copper. So when there is a new bond formation between the copper methyl group of the copper and CH2 group of the allyl, then this bond pair is moving over here. When this bond pair is moving over here, this chlorine will go out. Chlorine will go out. So that is how a compound is obtained. Okay. So this CH3 is obtained from the methyl of organocopper compound, and this is a byproduct. It will go out. So I think you are aware about this is one more thing. This compound is called acetoxy. COCH3 is called acetoxy. Acetoxy, a double bond containing compounds. So what will happen here? This methyl group attached to a sp2 carbon atom, but does not attack this carbon. Okay, so that is the difference. Okay, all you need to remember dimethyl cuprate attacks this particular double bond, means sp2 carbon atom, not the sp3 carbon atom. So that's what you need to remember. So there will be a new bond formation between this carbon and the methyl group of the copper. So when there is a new bond formation between the methyl group of the copper and this carbon, this bond pair is coming over here, and this acetoxy is a living group. It will go out. So that is how the product is obtained. This is the product is obtained. And then I will take one more. What is the name of this compound? This here also acetoxy is there. Okay, here also acetoxy is the living group. Then there will be a new bond formation between this carbon and this carbon. So when there is a new bond formation between this carbon and this bonded pair is going over here and this acetoxy is going out. So that is how the product is obtained. So I think here I am taking the propargyl acetate. So this is the propargyl. So propargyl means triple bond containing carbon. Okay, such compounds are called propargyl compounds. And here we are taking a propargyl acetate. Okay, so this compound is called propargyl. It's a general name. Okay, triple bond plus carbon is called propargyl group. So that triple bond carbon is attached to a acetoxy group. That is the reason it's called propargyl acetate. So what will happen? A propargyl acetate when it is treated with dimethyl cuprate. So that means there will be a new bond formation between this carbon and this carbon. So once there is a bond formation between this carbon and this bond pair is going over here. When there is a movement of this bond pair to here, then acetoxy will be the living group. When the acetoxy is going out, a compound is obtained is called alene compound. So what is the difference between alene and allylic? Allylic means double bond CH, CH2 group is called allylic. What is alene? Alene means double bond, double bond. So double bond is called alene group. Of course, alene will exist in a stereomers. Okay, alene stereochemistry. I think you are aware about it. So when there is a plane of I think these halenes are exhibiting the stereochemistry because of the chiral plane. Okay, so when the plane is passing through like this, more particularly this carbon, if other side, okay, both the side, A and A dash, B and B dash. A and A dash should not be the same, B and B dash should not be the same. But in this case, B and B dash is same, so that is the reason this moiety is not chiral active because of chiral plane of chiral compound. So this is not active because both the sides CH3 are there. If this CH3 is different means then there is a possibility of exhibiting two compounds. Okay, right. And here, so this is one more example. Of course, this might also contain a propargyl acetate 1. So here, what is as usual, the methyl group, it is attached to a CH2 group, okay, CH of the carbon-carbon triple bond. When there is a new bond formation between this carbon and this bonded pair is going over and this bond pair is a living group, it will go out. So this is about the product obtained. And the name of this compound, so what you can observe, so this particular compound also, what you can observe, this is CH2, this is CH2, this is CH2, this is CH2, and this is CHOH. So this also, it's not optically active because A and A dash is the same compound. That is the reason. Of course, the compound is alene. So with this, I will go to the next slide. So next slide is about the reaction with the epoxide. So epoxide means a three-membered ring with oxygen. Okay, is called epoxide. So more particularly, ring opening reactions occurs when dimethyl lithium cuprate is added to a epoxide. So that means there will be a new bond formation between this methyl group and this carbon. What is this carbon? This carbon is the less hindered carbon, whereas this carbon is more hindered carbon. So that means methyl is added to less hindered carbon. So thereby it leads to the product, and the product is inversion of configuration. So why this is inversion of configuration? Because it follows SN2 reaction. And what is the other thing? Yeah, that's all. So here also I am taking one more epoxide. So this epoxide also, when it is treated with the dimethyl lithium cuprate, so it gives trans product. So the obtained stereochemistry of the product is trans. This is also a trans. Okay, so here I am taking a few more example. This epoxide is a cis epoxide, but when it is react with the dimethyl lithium cuprate, the product obtained one is trans. Similarly, here I am taking one more. Of course, this is also a proposal related one, and there will be a new bond formation between this carbon and this carbon, and the bond pair is coming over here, and there will be a ring opening. So the obtained allene, okay, this is a, of course, what you can observe now. So this allene is a stereochemically uh, optically active compound, because the groups attached to this double bonds are different. This is different, this is different. And here, this what is called as H and CH3 is different. This is optically active allene compound. So you can find out the R and S configuration of this moiety by using the MP rule. Then I will take one more example. So this is also a epoxide, more particularly methyl isopropene epoxide. So what it will do, it won't attack the epoxy carbon, but it will attack a sp2 carbon atom. So there will be a new bond formation between the uh, methyl of the copper and the sp2 carbon atom. Once there is a new bond formation, this bond pair is going over here, and this bond pair, okay, picks up proton, and this will picks up proton, forming a enol. Okay, enol. It's not an enol. It's not a alpha enol. It's a beta enol is obtained. And then reaction with acid chloride. Acid, what is the functional group of the acid chloride? COCl. Okay, COCl containing compounds are called acid chlorides. So here cyclohexyl carboxyl acid chloride, when it is treated with isobutyl, okay, diisobutyl lithium cuprate. So diisobutyl lithium cuprate. So what it will do? There will be a new bond formation between the this bonded pair and this carbonyl carbon, and Cl is going out. So similarly, here I am taking acid chloride as well as alkyl halide. This is an alkyl halide, and this is an acid chloride. As you are aware that acid chlorides are more reactive compared to the alkyl halide. So that is the reason, if we are using a one equivalent of what is called as dialkyl lithium cuprate, so what it will do, it replaces this acid chloride. So that is what the ketone is obtained. Suppose if we are using a 2 equivalent, then there is a replacement of other halide which is attached to the same compound. So that is the reason 2 methyl groups are obtained. And then reaction with the alpha beta unsaturated acid chlorides. Of course, this is not a alpha beta unsaturated chloride. So this example is the alpha beta unsaturated. I think this structure is repeated, isn't it? Here also is there. Okay, the structure is repeated. And what is this? This is a alpha beta unsaturated acid chlorine. So that means this chlorine can be replaced with ethyl group of the copper attached one. So the product is methyl ketone. Alpha beta unsaturated ketones are obtained. So this is about what is called as substitution reactions of organolithium, more particularly Gilman reagent. Okay, so one more parameter is there, that is called uh, 1,4 addition reactions of organocopper reagent. So that maybe I will discuss in my next class. And if you have any doubts up to this, you can ask me. If there are no doubts, maybe you can log out.